Hello, everyone. Welcome back. Today, we'll learn about the sum of difference formulas. So our goal is then to be able to kind of understand the formulas, what they do for us, and also be able to use these formulas then to find values for trig functions. So let's take a look at these sum and difference formulas, why they call the sum and difference formulas. So or is for either sum or difference of angles. So either a plus b, you want to find the trig functions for the angle a plus b, or a minus b. Okay, and what this formulas do for us is if we know the values of the trig functions or know for the angles a and b by themselves, and these formulas then allow us to find the sine, cosine, and tangent for a plus b or a minus b. And also then the other trig functions, cosecant, secant, and cotangent, are just the inverses of these. Now, so let's take a look at the first one, sine. If you notice here, look at the signs, a plus or minus. So what we're going to do is we're going to see a plus for the top sign, you use the top sign here, okay? So if it has a plus b, I will use a plus here. This is the top sign. Use the bottom sign, a minus b, they have a minus here. Notice the cosine is very similar in format, but actually the signs are opposite. So if you use a plus here, a plus b, use the minus in the middle. Then if it's a minus b, use the plus. And then tangent looks like this, and the same kind of way of doing the signs here as well. So if you start with the top sign, plus, it's plus here and minus down below. If it's a minus b, it's a minus here and a plus down below. And once again, what these allow us to do, if we know the angles that we can find, or easily find the values of the trig functions for the angles a and b, then we can find them for either the same values, the sine, cosine, and tangent for a plus b or a minus b. Let's look at some examples how we can use this. And also I've included in this the unit circle to help us out finding some of these values. So let's say our directions might be like to find the exact value. Okay, so number one, let's say we have this. So I want to find the sine of 105 degrees. Okay. Now, so think about, if you look at our unit circle, think about our typical values. 105 degrees, remember in this unit circle, our degrees are in red. 105 degrees is not one of our angles on here. So we can't use this unit circle directly to help us. What we can do then is think about what can we add or subtract, angles can we add or subtract to get 105, okay? Now, we can actually do it either as addition or subtraction. What I'm going to use then is, it's easiest to look about the angles in the first quadrant, okay? 105 is the same as 60 plus 45. So 60 degrees plus 45 degrees, okay? Now, so the only thing we could do, we could also do, if you want to do, we could also, for example, 150 minus 45. That would also give us 105, okay? So that's not the only option, but this is a good option. Let's do this, okay? So what that tells us then is that the sine of 105 degrees is equal to the sine of 60 degrees plus 45 degrees. And also one thing we should probably mention here is you can't distribute the signs. This is not the same as 60 degrees plus the sine of 45 degrees, unfortunately. So let's use our formula. Let's go back up here and then we'll find our values, okay? So we're doing sine plus, so the first part is the sine of the first angle times the cosine of the second angle. That's the sine of 60 degrees times the cosine of 45 degrees, okay? Then, since we started with the plus here on top, use the plus here, plus, then we just switch these. So this would be the cosine of 60 degrees times the sine of 45 degrees, okay? Now, let's use the unit circle then to help us find those values. Okay, so remember the unit circle, it has center is at the origin and the radius is 1. And if you're on the unit circle, then your x-coordinate is the cosine of that angle, and the y-coordinate is the sine of that angle. So the unit circle makes this simple, okay? So for 60 degrees, cosine is the x-coordinate, which is 1/2. The sine of 60 rather, then is the y-coordinate. That's the square root of 3 over 2. Now for 45 degrees, with the cosine of 45 degrees, that's the x-coordinate at the 45-degree angle, okay? And that's the square root of 2 over 2. Okay, then once again plus, And the cosine of 60 is x coordinate at 60 degrees, which is 1/2. And then sine of 45 is the y coordinate at 45 degrees, which is also the square root of 2 over 2. Okay. Now multiply each one of these across. So our denominator is going to be 4, 2 times 2. And then remember, as long as you have multiplying radicals, as long as it's the same radical, as long as in this case are both square roots, multiply what's on the inside. So the square root of 3 times the square root of 2 is the square root of 6. Okay. And over here, multiply across, and so we have the square root of 2 over 4. And then, since these have the same denominator, let's combine these into one fraction. So the square root of 6 plus the square root of 2 over 4. Okay, and that's the exact value. Now, also, if you preferably like to simplify these square roots if you can, in this case, either square root simplify, so this is our exact value. Okay. Then, of course, you can also approximate that with a calculator if you want. Okay. Let's take a look at another example. Number 2. This time, let's do the cosine of pi over 12. Let's do one in radians. Now, this one is a little bit harder to see. Okay, this one's a bit trickier. So you have to think about a different way with radians. Okay, so once again, pi over 12 is not one of our angles listed here. Okay, but what we can do is we can actually write this pi over 12 using these angles. Also focus on these angles in the first quadrant. Okay, so it might be easier to think about these angles here, 60, 45, and 30, with the denominator of 12. Okay. And so what we have then is pi over 6 is the same as 2 pi over 12. Pi over 4 is the same as 3 pi over 12. Then pi over 3 is the same as 4 pi over 12. Okay. Now, if we look at those three angles in terms of the denominator of 12, the same denominator as this, we can see that actually if we do pi over 3 minus pi over 4, that will actually give us the result we want. So 4 pi over 12 minus 3 pi over 12 is pi over 12. So 4 pi over 12 minus 3 pi over 12 is equal to pi over 12. So what we have then is that gives us the pi over 3 minus pi over 4 is equal to pi over 12. Let's use that. And once again, that's not the only thing you could use. That's probably the best thing in this case. Okay. So the cosine of pi over 12 is the same as the cosine of pi over 3 minus pi over 4. Okay. Now, once again, we can't distribute this. All right. Once you go back and use our formulas, it's similar to the sine formula, but not exactly the same. This time we're doing a minus, cosine minus. Okay. So the first part of it is the cosine of each angle multiplied together. So this is going to be, sorry about that. So it's going to be the cosine of pi over 3 times the cosine of pi over 2. That's the first part. Then, since we did the minus in the bottom sign, use the bottom sign here, it's going to be the plus, and then it's going to be the sine of each angle. So the sine of pi over 3 times the sine of pi over, not pi over 2, pi over 4. I'm sorry, that should be a pi over 4. Okay. Now, then let's go to the unit circle to find these values. Actually, these same values we used before. Right? The cosine of pi over 3 is x coordinate here is 1/2. Cosine of pi over 4 is the square root of 2 over 2. The sine of pi over 3 is the y coordinate of pi over 3, which is the square root of 3 over 2. And then finally, the sine of pi over 4 is actually the same as the cosine of pi over 4, which is the square root of 2 over 2. Okay, multiply these across, and so we have first term is going to be the square root of 2 over 4. And the second term is going to be plus square root of 6 over the square root of 4. And so this turns out to be, just by coincidence, the same result we got before for the sine of 105. So don't, the square root of 2 plus the square root of 6. Okay. turn out to be exactly the same as what we saw before for the sine of 105, but that just turns out to be a coincidence. Okay, they're not really that related. You just have to work out that way. Okay, do a different angle, you get a different result. That's how it works. All right. Now, let's do a couple more. And give me just a moment. Okay. Let's take a look, just going down the next page. Now, let's just practice these in a slightly different way. All right, so what if we have this? So let's say we have cosine of 83 degrees times the cosine of 53 degrees plus the sine of 83 degrees times the sine of 53 degrees. Okay, so here we just just practice with these identities. Let's see if we can match up what this is. Okay, so you have a cosine times a cosine, then plus a sine times a sine. So if you look at that, the ones that really fits would be the cosine of a plus b. In this case, since we have a plus in the middle, that means we have the bottom, that's the bottom sign here, is use the bottom sign over here, then that means this is the same as cosine of 83 degrees minus 53 degrees, okay? And that, of course, is the same as the cosine of 30 degrees. And the cosine of 30 degrees is the value we know from the unit circle. Let's take a look. Cosine of 30 degrees is the x-coordinate of that point, and that's going to be the square root of 3 over 2. All right, I'm not sure why it keeps doing that. Okay. All right, let's do another one similar to that. That was number 3, number 4. All right. Let's use hang on just a moment. Let me decide for sure what I want to do. Okay. This time in a similar one, let's say we have the tangent of 33 degrees plus the tangent of 12 degrees. Okay. That's over 1 minus tangent of 33 degrees times the tangent of 12 degrees. Okay. Now, obviously, the only one we could fit would be this one. The only one that involves tangents. So the question then, is this going to be tangent plus these angles or minus? So let's look at the signs. The sign here is plus and the bottom was minus. So those are the top signs. Plus here and then minus here. So this is going to be a plus b. This is the same as the tangent of 33 degrees plus 12 degrees. Okay. And that's the same as the tangent of 45 degrees. Okay. And if we look at our 45 degrees, our tangent is the same as the sine of 45 over the cosine of 45. Okay. And in this case, that's just the square root of 2 over 2 in both cases. And so the tangent of 45 degrees is just equal to 1. Okay. All right. Let's take a look at one more example. Okay, this should be number 5. Now, let's say we're given this 4. Let's say we have the sine of some angle u is 3/5, and angle u is in quadrant 1. Okay. Then we also have the sine of some angle V is negative 12/13. And then V is in quadrant 3. And we want to do that is we want to find the sine of U plus V, cosine of U plus V, and then the tangent of U plus V. Okay. Now, first off, the best thing to do is just draw a picture of this. Okay. So our angle U is somewhere in quadrant 1. We know that. Let's say it's right here. We don't know exactly where. Okay. But we know then is that the sine is 3/4/5. Remember, sine is in terms of x, y, and r coordinates, and where r is the distance from the origin, sine is y over r. So this is the same as 3/5. And so this is, let me call this x1. Okay. Remember, r is the distance from the origin. And since we're in quadrant 1, all these are positive. Now, I won't show the details, but you can use the Pythagorean theorem to find out that this x1 is equal to 4. Okay. Now, quadrant angle V is in quadrant 3, so I think it may look something kind of like this, kind of long angle like this. So this is angle V. If we make another triangle and do the same idea, so we have sine. Sine is y over r. So this is negative. Make sure this is negative. This is negative 12/13. Okay. This is negative 12. This is 13. Okay. And this x, I'm going to call x number 2, x2. The same way I've used the Pythagorean theorem, it turns out this is 5. And since we're in quadrant 3, x and y are both negative, so this is actually negative 5. Okay. The reason we do that then is to find our values of our sine functions. Okay. So the sine of u plus v is, from our definition, the sine of u times the cosine of v plus the sine of the cosine of u times the sine of u. Okay. Then we can plug those in. All right, plug in the values. So we know the sine of u is 3/5. Okay. And the cosine, since now we know the cosine is v, angle V, that's right here. Cosine is x over r, so that's negative 5/13. And from our picture, then plus, then the cosine of u, okay, once again, cosine is x over r, so of angle u, that's 4/5. And the sine of e we're given, the sine of e was negative 12/13. Okay, now once again, multiply across, that's going to be negative 15/65 here. Then plus, or sorry, actually will be minus, plus a minus. Since this is minus negative 48/65. And that, if you multiply those or add those together and bring it to 1, that's going to be negative 63/65. So this is the sine of u plus v. Okay. Now, do the same thing for the cosine. So the cosine of u plus v, okay, our formula is the cosine of both angles, so the cosine of u times the cosine of v, then minus the sine of u times the sine of v. We have all the same values we just found right here, okay? So cosine of u, remove my picture there, cosine of u is 4/5, okay, from up here. The cosine of v is negative 5/13. Okay, then minus. Then the sine of u is 3/5. These are the values we're given. The sine of v was negative 12/13. Okay, and then just say do the same thing. Multiply across to negative 20/65. Now we're just going to be minus a minus is going to be plus, and that's going to be 36/65. Okay, we combine those, that's going to be positive 16 over 65. That's the cosine of u plus v. Okay. Now, find the tangent of u plus v. Now, actually, we can do this a couple ways. We can use the formula, and what you have to do here then is you'd have to find the tangent of these angles. Okay, remember, tangent is y over x. You have to find the tangent of those. Okay, and plug those in that formula. But actually, something a lot easier to do. Just from our rule, the tangent is the same as the sine of u plus v over the cosine of u plus v. Okay, that's true anytime tangent is always sine over cosine. So this is going to be, so the sine was negative 63 over 65. And then over the cosine, which is positive 16 over 65. Okay. Then we know to dividing fractions multiplied by the reciprocal of the denominator. So that's going to be minus 63 over 65 times 65 over 16. 65s cancel out, and we have then negative 63 over 16, and that is the tangent of u plus v. That's actually good practice for you to do on your own, is actually plug it in here and see if you get the same thing. Okay, so that's how we can use the sum of difference formulas then to approximate angles if we know. So in this case, we don't even know what u plus v is, or actually don't know what any of the angles are, but we do know then how to find the, because we know the values of the other, of u and v separately, we can find then u plus v also do the same and find u minus v. Thank you. Have a good day.